In this video, I want to have a look at z-scores. So a z-score is also called a standardized score, and it shows the position of a raw score relative to the mean. So for example, a z-score of 1.8 means that the raw score is 1.8 standard deviations above the mean, whereas a z-score of -2 would mean that the raw score was 2 standard deviations below the mean. To calculate the z-score, we'd have to take our original score and subtract the mean, and that'll tell us how far away it is from the mean. But because we want that in terms of standard deviations, we'd then have to go score minus mean divided by standard deviation. We can write that in a formula as z equals x minus x bar, which is our mean, divided by s for standard deviation. We can actually use this formula to find any of these pieces of information if we're given the other three. So for example, if we were given the z-score, the mean, and the standard deviation, we could work backwards to figure out what the original score was. This formula is on your formula sheet in the HSC, but you need to be familiar with it and know when and how to use it. The first example that I want to have a look at says Brooke achieved a mark of 70 for a class test. What is her z-score if the class mean was 78 and the standard deviation was 6? Now, before we start using our formula and calculating anything, I want you to stop and look at this question and have a think about what our answer might be. So if she achieved a mark of 70 and the class mean was 78, that means that her z-score is going to be negative because her score is lower than the mean. Now, if we think about how big it's going to be, if the standard deviation was 6, one standard deviation below the mean of 78 would be 72. So if she had a score of 72, then her z-score would be -1. Hers is, she got 70 though, so her z-score is probably going to be a little bit less than -1. So now that you've estimated it and we know roughly what our answer should be, we can actually do our calculations. So if we write down our formula, so z equals x minus x bar over s, our score was 70, the mean was 78, and the standard deviation was 6. And if we put that in your calculator, it'll come out with -1.3 if we round it to one decimal place. So that's pretty much what we were expecting, -1.3 standard deviations below the mean. Our second example says Jordan achieved a z-score of 2.5 for a reading test. The state mean for this test was 71.5 and the standard deviation was 6.4. It then asks us what Jordan's raw mark was. So again, before we start doing anything with the formula, I want you to sit and interpret this first. So a z-score of 2.5 means that he's 2.5 standard deviations above that mean. So that's looking pretty good so far. But I want you to think about how good it is. So if you think back to our lesson where we had our normal curve, from our mean, if we went one standard deviation each side of that, we had 68% of our scores in there. If we went 2 standard deviations either side of our mean, that was 95% of our scores. So that means above that 2 standard deviations above the mean, above that there's only 2.5% of people within that score range. So if Jordan's getting a z-score of 2.5, that's up here somewhere, there's not a very large percentage that are getting very much higher than him. Okay, so that's a really good score. So let's figure out now what it actually is. So we'll use our formula, z equals x minus x bar over s, and fill in what we know. So we know his z-score is 2.5. We don't know his original score, that's what we're trying to find. But we do know that the mean is 71.5, and the standard deviation is 6.4. So to figure out what that x is, the first thing we're going to do is get rid of this 6.4 by multiplying. So if we do the 2.5 times 6.4, we would end up with 16 is equal to x minus 71.5. And then to figure out x, we're going to add that 71.5 to the 16, and we would end up with x equals 87.5. So here he's got a raw score, or raw mark for that test of 87.5. So the whole point of z-scores is that they help us to compare data that comes from two different data sets. So for example, if you sat a maths test and an English test, getting a higher mark in one doesn't necessarily mean that you've done better in that test. Maybe it was just an easy test. So z-scores allow us to compare how well you've done relative to the bulk of other people, so relative to the mean. So it's really good for comparing scores from two different data sets.